Hey all, welcome back to Text to Action series where we build intelligent systems that transform natural language into real world actionable outcomes using AI. Today we will see how we can build a smart calendar AI assistant that constantly listens for a wake up word detection and converts that to a calendar event. Before we jump further, let's have a quick peek over how exactly the outcome of this specific episode is going to look like. Let's ensure that there are no other calendar events that are currently available. Let me switch back to this specific URL. In step one, we have to ensure that the authentication to access the Google via its API is being completed. In step two, we are going to enable the wake word detection feature. So if I click this button,
Wake word detection enabled.
so it's being enabled. Now, as you can see here, all the conversation that I'm having right now is being transcribed in real time and it can appear, it's appearing right now under this specific box. Now, as soon as I start mentioning any wake up word, it's going to create the calendar event for us. Now, as you can see here, my hands are here. Now, if I say, hey calendar, schedule a team meeting tomorrow at 2 p.m.
Yes. Processing your event created. Team meeting.
Cool. So you did create it as expected. That's really good. Now, just in case to make sure that it's working properly, let's do one more test. Hey, calendar, create a dentist appointment tomorrow at 10 a.m. for 1 hour.
Yes. Processing your event created. Dentist appointment.
Okay, it did create it as expected. Great. Now let's proceed further to really understand how exactly everything is being connected end to end. Before we go deeper, let's try to understand what's built so far, the infrastructure, the backend infrastructure that actually powers these things. In part one, we have created the initial foundation to access the Google Calendar's API through an exposed API endpoint. In part two, we have added the NLP capabilities, enabling users to type descriptions like schedule a team meeting tomorrow at 3 p.m. and transform these words into calendar events. In part three, we have implemented a voice commands processing feature where the user can press and hold a microphone button and it creates or simulates a hands-free way to schedule events. Today, we are going to implement a wake up word detection feature, which is going to provide a true hands-free calendar management by simply saying the wake up phrase, hey calendar. Imagine you're building a Google Calendar like assistant where it's continuously listening for the wake up word detection and it processes your voice commands to complete a specific action, in this case, a calendar creation event. So, what are we building today? The complete end to end code is available in this specific GitHub repository. Feel free to check it out to dig deeper. Let's have a quick walkthrough on the core code implementation. First, we set up the continuous listening process. We rely on WebSpeech API where we first initialize the recognition object. We enable continuous listening and we set the language to be US, English, and we set the interim results to be true so that we can capture whatever the text being converted during this complete flow before the listening stops. The heart of our system is the speech recognition processing that listens for hey calendar wake word. In the instantiated recognition object with the on result lifecycle, we are able to constantly listen to the transcribe speech to text events, and we are able to tap into all those events and construct the actual final transcribed words. And once that's done, we would call process transcript, where we would check whether the hey calendar text is being available in the final transcript that is being created, which feels very simple and effective. Now, once that's done, we would call the handle wake word command function with all the information. In the handle wake word command, we would enable that the processing is happening and we will show a visual feedback. And then we would extract the actual voice command, removing the hey calendar trigger word. And once we have those command value, we would have a voice feedback saying that it's being currently being processed. Once the command is available, we would call the process voice command function, which would process the entire text and pass all the voice command text and call this specific API endpoint, and it will be able to take care of the rest in creating the event. And once the key event is being created, we are calling the speak function, which is a speech synthesis function of web speech API to give us a audio feedback that the event is being created. If you would have noticed how we are simply sending the recognized speech text to our existing API endpoint from part 2, this demonstrates a good architectural design where we can literally reuse everything and achieve our end goal. So just to have a quick overview, we literally reused our API endpoint from part 2. It leverages Google Calendar integration from part 1, and it uses the same voice synthesis capabilities from part 3. In regards to the visual and voice feedback, you could see that the wake up word, if it's enabled, there is green. If it's yellow, which it means it's processing. And if it's gray, it means the wake up word is off. And there is also voice feedback where it would keep the user informed of the process that is happening so far. You could refer this section to test everything locally in your machine as well. So this concludes the complete text to action journey. That's for part 4, where in part 1, we create the events with structured JSON request. In part 2, we created NLP. In part 3, we did a manual voice activation when you're ready by press and hold interface. And in part 4, we have enabled always on wake up word function. One among the limitations where it's very concerning is the accuracy and consistency in reliably enabling the wake up word detection using web speech API. These limitations highlight why we should use machine learning techniques to improve the reliability and have also the flexibility to have different custom wake word. So this concludes the tutorial. Hope you enjoyed it. I will see you in the next episode. Take care.